Welcome back. In today's class, we will solve different problem sums based on cardinal numbers. So let's start. First problem sum says that set A, it has the elements which are the letters of this word integrity, and set B has the elements which are the letters of this word reckoning. Now first we have to form those two sets. A will have these elements. Here set A will have 7 elements, though the word integrity has 9 letters, because I has been repeated here twice and also T is appearing here twice. But since we don't consider any repetition in a set, so I and T, these two elements, will be considered only once as element of set A. So cardinal number of set A is what? Cardinal number is 7. Next we will form set B and we will see that how many elements it will have. So it will start with R, and this set B will have in total 8 elements. In this word, only this alphabet N is repeating twice, but here in set A we will be taking only the unique alphabet. So the cardinal number of set B will be 8. Now based on these two cardinal numbers, we have to verify these two relationships. So let's proceed one by one. First, in a first problem, on the left hand side, we have to find the cardinal number of this union operation between A and B. So first we will see that what new set we can get when we will perform union operation between set A and set B. So it will have these elements, and here we can see that we have 10 elements in this new set, which is the resultant of this union operation. So cardinal number of this union operation is 10 here. Now on the right hand side, if we come, then n of A, this cardinal number, and n of B we have already found. Now next we have to find this cardinal number. Before that we have to perform this intersection operation between A and B. So first we will perform this intersection. So A intersection B, that means we will have in the new set, in the resultant set, we will have only the common element. So if we consider the common elements, then we can find here, we can see here that I is common between A and B. So we will write I here. N is also a common element. So N we will consider. Then T is not common. Then E is an common element between these two sets. Okay, then we will consider G also, because G is also common, as we can see. R is also common between them, so we will consider R as well. And Y is not common. So we have only 5 elements in the resultant set. So the cardinal number of this intersection operation is 5. So from the left hand side, this is our result, which is 10, and from the right hand side we have to perform this addition. So n of A plus n of B, then minus n of A intersection B. N of A we have already found, which is 7. Then n of B we have also found, which is 8, and then minus 5. So it is 15 minus 5, which is 10. So left hand side is equal to right hand side. Now the second problem, what it says, what we have to verify is, first we have to find the cardinal number of this union operation that we have already obtained, which is 10. And then the right hand side, this addition we have to perform, and before that this cardinal number of the intersection operation also we have already found. Now we have to perform these two things, these two operations, these two difference. So first we have to find the difference between A and B. And difference is what? Difference is, first we will consider all the elements of A which don't belong to B. So first we have to find those such elements. So here in this new set, resultant set, we have only 2 elements which belong to A but don't belong to B. So cardinal number of this difference operation between A and B, that number will be 2. Next we have to perform the difference between B and A. So that means we will consider those elements of B which belong to B only, but they don't belong to A. So we have found three such elements. That means cardinal number of that difference operation between B and A is 3. Now what operation you have to perform next? The addition. So n of A minus B plus n of B minus A and then plus n of A intersection B. So the first cardinal number is 2 that we have found. Then the cardinal number of the second difference operation is 3 and cardinal number of this intersection operation is 5. So in total it will give us 10. And from the left hand side also we have seen that that number is 10. Hence this relationship is proved. Next we will verify two more equations based on the same sets. So again the cardinal number of A we have already found. We have seen that that cardinal number was 7 and cardinal number of B that was 8. Here the first part of the equation has the cardinal number of the difference operation between A and B, and that we have already obtained, and that is 2. The cardinal number of this difference between A and B, that is 2. So we are writing here 2. Now next is the cardinal number of the union operation between A and B, and from that we are subtracting the cardinal number of B. Now this cardinal number, this if of this union operation that we have already obtained, and that is 10, and cardinal number of B is 8. So it is 10 minus 8, which is 2. So the first part and second part are equal. Now the next is n of A. From that we are subtracting the cardinal number of this intersection operation between A and B. So n of A is 7 that we have already seen, and the cardinal number of this intersection operation is 5. So here it will be 7 minus 5, which is again 2. Hence it is proved. The first part, the first problem sum. Now the second problem sum, it says again here we have to first find the cardinal number of this difference operation between B and A, and that we have already found, and that is 3. The cardinal number between the difference operation between B and A, that is 3. And the second part, it says that we have to find the cardinal number of the union operation between A and B, and from there we have to subtract the cardinal number of this A. Of this union operation, this value is 10 and n of A is 7. So 10 minus 7, it is 3. Now the third part is n of B minus n of the intersection operation between A and B. N of B is 8 that we have already obtained, and the cardinal number of this intersection operation is 5. So 8 minus 5 is 3. So all these three parts have the same value, and that is 3. Hence it is proved, the second problem sum. Now the next problem says that if the cardinal number of the difference between A and B is 12 and the cardinal number of the difference between B and A is 16, and if the cardinal number of the intersection operation of A and B is 5, then find all these values. Let's solve the first part where we have to find the cardinal number of A, and before that let's revise the properties of the relationship of related to cardinal numbers. Now we know that the cardinal number of the difference between A and B is equal to the cardinal number of the union operation between A and B minus the cardinal number of B, and that is also equal to cardinal number of A minus the cardinal number of the intersection operation between A and B. Similarly, when we consider the cardinal number of the difference between B and A, then it is equal to again the cardinal number of the union operation, and this time this cardinal number of A will be subtracted, and that will be also equal to n of B minus the cardinal number of the intersection operation between A and B, or B and A. Now here what we have to find is n of A for the first problem. So n of A we have here and also we have here. But we also, the data we have to see that what data are given or available to us. Here the value, the cardinal number of the intersection operation is available. So we have to consider this, the second part of this relationship. So here we have NA here. So we have to consider this formula. So we will take this relationship. Now the cardinal number of this difference operation is given and that value is 12. So here we will write 12 and also the cardinal number of this intersection operation is given, which is 5. So only unknown parameter here, it is n of A. So n of A we can easily find and that will be equal to 12 plus 5, which is equal to 17. Now the second problem sum says that we have to find n of B, and for that the approach will be same. Here n of B we can find from this second relationship. So n of B minus A is given in the problem sum, which is 16. N of B we have to find and n of this intersection operation is given, which is 5. So here n of B will be 16 plus 5, which will be equal to 21. So these two values we have obtained. Now the third part. Third part we have to find the cardinal number of the union operation. Now for union operation we have these two relationships, the first part and here the first part. And for that we need the information of this cardinal number of the difference and at the same time either n of B or n of A, whichever, depending on whichever we are choosing. So suppose if we choose the first one, so here n of A union B we have to find, and for that this relationship we will be choosing. So n of A minus B will be equal to n of A union B minus of n B. So here n of A minus B is given, which is 12. N of A union B we have to find and n of B we have already found and that value is 21. So here the value, the cardinal number of this union operation between A and B will be 12 plus 21. That means it will be 33. So this is how we solve the problem sums related to cardinal number. Now let's see what is waiting for us next. This problem sum says the cardinal number of an universal set is 40. Cardinal number of complement of A is 15. So from this two given data we can say that cardinal number of A will be 40 minus 15. Since 15 is the cardinal number of the complement. Complement means here cardinal number is what? Number of elements. Here the total elements of this universal set will be 40. Now suppose the number of elements of set A is x, and this x number of elements, they will be also the elements of this universal set. Now what is the concept of complement set? Complement set will have the elements which will not belong to this set A. If we are talking about complement of A, then under this set, under this complement of A, we will have the elements which will not belong to A but they will belong to E. So the number of elements when we will form this set A, then the number of elements which will be left behind, they will be part of this complement of A. That means this, if suppose the complement of A with the data is given, that is 15. So 15 is the number of elements which were left behind after forming the set A. So this many elements, and then if we add the number of elements which we took from E to form A, then when we will add these two, they will count basically 40. So 15 plus x will be equal to 40 and x will be 40 minus 15, that will be equal to 25. So here the cardinal number of A will be 25. Now again the n of b is given the cardinal number of set B, and that is 12. So that is directly given. So n of A we have found, which is 25. N of B is given, that is 12. And there is another relationship that is given, and that is the intersection operation between A and B and complement of that, and that value is 32. So every value will be based on this universal set only. So the cardinal number of the complement of the intersection operation is 32. That means cardinal number of this intersection operation will be what? It will be based on again the universal set. That value is fixed, which is 40. So 40 minus 32, that value will be 8. So cardinal number of the intersection will be 8, because the cardinal number of the complement of the intersection is given as 32, and the cardinal number of the universal set is fixed, and that is 40 for this problem. Now based on these values, we have to find all other values which is given here. N of A we have already found. So the n of A, the first part of the problem, that is already been done, which is 25. Now n of B complement we have to find. Again the concept is same. So n of B is, since it is 12 and complement will be found based on the universal set, so it will be 40 minus 12, which will be 28. Again the concept is same that I have already discussed for A, so I am not repeating that concept. Now the third is the cardinal number of this intersection operation between A and B, and that we have already obtained, that is 8. So this problem is done. Next we will solve other three problem sums based on the same sets. Now in the first part we have to find the cardinal number of the union operation, and we have already learned, we know this relationship, that it will be equal to NA plus NB. So first all the elements of the first set we will consider, then all the elements of the second set we will consider, and if there is any common element, that we have to discard, because we will consider the elements only once. So if there is any repetition, then we have to discard that, and that we can do based on the intersection operation, because in intersection operation we consider only the common elements. So here we will subtract the cardinal number of the intersection operation between A and B. N of A we have already obtained in the first part of the problem, and that was 25. So directly I am putting that value. Then n of B is given in the problem sum, and that is 12, and n of A intersection B also we have found in the first part of the problem, and that was 8. So it will be minus 8. So it will be 37 minus 8, which is equal to 29. So this is our answer of the first part. Then second part, it says that we have to find the cardinal number of the difference between A and B, and we know this relationship, that when we are finding this difference between these two sets, then it will be n of A minus n of the intersection between these two. So it will be n of A means 25, and this for this intersection the value is 8, so it will be 17. Again we have another relationship, and that is n cardinal number of the union operation minus n cardinal number of the second set. So the union operation we have already performed, and that value is 29, and cardinal number of the second set is 12, that is given, and that value is 17. So from either one we can find those value. Now the third part of that problem sum, it says that we have to find the cardinal number of this difference operation between B and A. It is the second set minus the first set. So here the relationship that we will use here is n of B minus n of A intersection B. So n of B, that value is 12, which is given, and n of A intersection B, that value is 8. So this value will be 4. And if we use this, if we want to find this value based on union operation, then it will be n A union B minus n of A. this time. So n of a, now it will be the union operation, the value is 29 and n of a is 25. So 29 minus 25, it is 4. So whichever relationship we use, we are getting the same value only. So the third part of the problem sum is also proved. So in this class we have solved various types of exercises based on cardinal number. I hope you have enjoyed this class. Thank you.